Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to CET JEE classes of complex numbers. Well, in the last class we have worked out some examples of basic concept of the complex number, and in today's class we will solve a few examples related to modulus and conjugate of the complex number. Let's look at the first question. I hope you guys are ready. Find the conjugate of 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus I. You just have to find the conjugate of this complex number. We'll express this in the form of a plus ib first, and then we will find its conjugate. I'm sure you know the meaning of conjugate, right? So what is the conjugate of a plus ib? It is a minus ib. Only the imaginary part changes the sign. Well, so let me consider that as z, okay, and then let me multiply it. Let's not write that again here. So directly I will write the answer of the multiplication. Okay, so 9i and then minus 4i, and then you have got minus 6i square. Yes, and divided by, say this is like 2 here, and then minus I. Now multiply 2i for both. Okay, 2i into 2, so that is 4i, and then 2i into minus I, that is minus 2i square. Let me replace I square. What is the value of I square here? Minus 1. So let us write minus 1 there, and these things can be simplified. So what do you get? 5i, 9 minus 4, right? And this is minus 6 into minus 1, which will be plus 6, and that can be added later here, divided by you have 2 and 4i minus I, 3i. So this is 2 plus 3i and minus 2 into minus 1i I square value minus 1. That is what we have replaced. Now let me write one more step here itself. So this is 6 and plus 6 and then plus 5i divided by I have got 2 and plus 2 here, and then plus 3i. Okay, so let me continue here. Well, now this is still z, so that is 12 plus 5i divided by 4 plus 3i. Now what you need to do is you should write this in the form of a plus ib. That's what we are trying to do here, right? So if you want to write that in the form of a plus ib, you should not have imaginary in the denominator. Okay, so you should not have iota in the denominator. So rationalize, multiply and divide by the conjugate of the denominator. Multiply, usual multiplication, so that is 48 and then 36i and then 20i and then minus 15i square, and then here a plus b into a minus b, therefore it is a square minus b square. Okay, well, so this is 48, and then I'll write this minus 15 and minus into minus 1 in the beginning because that's the real part, and minus 36 plus 20 is minus 16i divided by, you have got 16 here and minus 3 square 9 and then I square, which is minus 1, right? So this is 48 plus 15 minus 16i divided by, you have got 16 minus 9 into minus 1, which is 16 plus 9, that is 25. So this is like 48 plus 15, 63 minus 16i divided by 25. So if you just split this, you will get the complex number z. We have not yet got the conjugate of it. So what is the complex number, the given complex number z? That is 63 divided by 25 minus 16 by 25i. So this is the given complex number. Now you are asked to find the conjugate of this, right? So what is the conjugate z bar, and what happens in the conjugate? The imaginary sign changes, the imaginary part of the complex number changes its sign. So you will end up with 63 by 25 and this negative becomes positive here and 16 by 25i, and that's your final answer. Well, so what is the conjugate of the given expression? 63 by 25 plus 16 by 25i, and that's your answer. Well, let's move to the second question here. Find the modulus, right? So this is a straightforward question. You're asked to find its modulus. Okay, so let me just remind you what is the modulus. So if you have the complex number a plus ib, then the modulus is a square root of a square plus b square, right? So that's the formula to find the modulus of a complex number. So now let's go with the given expression, the given complex number, and that is 1 by 1 plus I, right? Yes. Now, is it in the form of a plus ib? No, it's not. So what are you going to do? Rationalize. So multiply and divide by the conjugate of the denominator. So 1 minus I divided by 1 minus I. So now multiply. So that is 1 minus I itself, because that's multiplied with 1, right? And this is a plus b into a minus b, therefore it is 1 square minus I square, which is like 1 minus I divided by 1 square. I square is minus 1. So this is 1 minus I and divided by 1 plus 1, which is like 1 minus I by 2, and hence what is the complex number z? 1 by 2 minus you can write plus I into minus half, right? Okay, so I'm just taking the denominator here and denominator there. This is minus I by 2, so minus I by 2, I have taken I common, minus 1 by 2 is the imaginary part. See, why did I write in this form? Because it clearly denotes a and b values, so that we can substitute here. Okay, now let's find the modulus. So the modulus of this is square root of a square plus b square. What is a square? Half square of it, and then minus half square. Well, so let's continue with that. What you have got here? 1 by 4 and negative, when you square it, you'll get positive, correct? Okay, so that is plus, and 1 square is 1 and 2 square is 4. Well, so if you take LCM 4, 1 plus 1 is 2, 2 by 4 it is. Okay, so 2 by 4, and that is 2 ones are 2 2s are, therefore it is root half. Now square root of 1 is 1 and square root of 2 in the denominator, because this root applies for both So take the root for the numerator and take root for the denominator as well. So 1 by root 2, where do you see that? Yes, option D. Hence option D is the right answer for the second question. Well, so let's move to the third problem here, and the third problem is based on the knowledge concept of modulus. Okay, let's see how we can use it. But what is z here? Okay, z is a complex number, so you can take it as x plus iy, or you can take a plus ib, doesn't matter. So we'll go with the x plus iy, because in the answers you see imaginary axis, real axis, right? So this is the real axis and y is the imaginary axis. Therefore a complex number we shall take it as x plus iy. Let z is equal to x plus iy. Okay, so we'll take a complex number with variable values of real and imaginary part. Now what is given? Z square minus 1 is equal to mod z square plus 1. Okay, so these two quantities are equal. Let's go with this. Now substitute z here. Okay, so z is x plus iy the whole square minus 1 is equal to x plus iy modulus square and then 1, right? Well, now let's continue with this. Let's square it first. Okay, so when I square this, what do I get? X square iy whole square plus 2 into x into iy, correct? And then I have minus 1 as well. That's equal to, now what is the modulus of z? Square root of x square plus y square. Now I need the modulus of z, modulus of x plus iy, which is square root of x square plus y square, and then I have whole square and then plus 1. Let's simplify this part. So this is x square I square and y square, correct? And then I have got 2x iy. I can take that I separate so that the imaginary part is clear, and then here square root and square will cancel each other. You will get x square plus y square and plus 1. So there is nothing much to do here. Okay, but continue with this. Now let us replace this. You have got x square and then plus minus 1 into y square, and I'll take I and 2xy here, and then minus 1, that is equal to x square plus y square plus 1. Yes, now this is like x square minus y square, and this is also real part, so we'll bring it together, and the imaginary part will take it separately. So if you separate the real part and the imaginary part, you will get this, right? And that's equal to x square plus y square and plus 1. Now this is like x plus iy, correct? So if the complex number is x plus iy, what is its modulus? Modulus is square root of x square plus y square. Now apply the same logic here. Okay, so you have got a complex number here, so this is in the place of x and this is in the place of y. Therefore now you got to write its modulus. So start with under root, right? And then you have got x square minus y square minus 1 the whole square. So this is x now. Okay, so x square is over, plus y. So in place of y I have got 2xy, so 2xy the whole square. And you know, longer write the modulus because you have written the modulus value here under root, right? And that is equal to x square plus y square plus 1. Well, now what do you do? You have to get rid of the square, right? The root, I'm sorry. So what do? Square both sides. So this is x square minus y square minus 1 whole square plus 2xy whole square, and here you have got x square plus 1 whole square. We have to square here and square here. Square and square root will cancel on the left hand side. So this is taking us very long. Let's cut it short. Okay, so now see what you have. You have got whole square. Okay, so what is this actually? So what is a plus b plus c whole square? That is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So this formula should be used here as well as here. So let me use it here. So you have got a square, that is x square the whole square, and then in place of y I have got this, correct? And right, so a, b and c, a, b and c. So now I should write b square. So this is minus y square the whole square, and then c square minus 1 the whole square plus 2ab. So 2 into x square into y square, and then I have got 2bc. So both are negative, therefore it will be positive, correct? And then 2ca, so c and a, so that will be minus 2x square and plus 4x square and y square. That is the left hand side. Use the same formula on the right hand side. Same formula on the right hand side. So that will give you first x square the whole square, y square the whole square, and plus 1, correct? And then plus 2ab, so 2x square y square plus 2y square plus 2x square. Now cancel the similar terms you see on the both sides. See, this is minus and whole square, that will be plus y to the power 4, y to the power 4, and then this is 1, and minus 1 whole square is also 1, and then you have got this is minus and this is plus, doesn't cancel now, and this is 2y square will cancel, right? Now what are you left with? You are left with 2x square and y square plus 4x square y square, and then this is minus 2x square, and on the other side you have got 2x square y square plus 2x square. Now so this is 4 and this is minus 2, so it will be 2x square and y square and minus 2x square. So hence this is 2x square y square plus 2x square, hence that also will cancel. So now finally you are left with only this. So this minus 2x square, take to the other side, becomes plus 2x square. So take to the other side. So what remains here? Okay, so plus, and what remains here is 0. So that is 4x square is equal to 0, x square is equal to 0, hence x is equal to 0. Now what is this? What is this? So does it lie on, see what did we get? We took z is equal to x plus iy. Now we got x is equal to 0, therefore z is iy, correct? because x is 0. So now you got only I, y. So where is it? See, this is x axis and this is the y axis. So you have got x 0, correct? So if x is 0, where is your complex number? See, this is x is equal to 1, 2, 3 and all. If x was 1, then your complex number would be anywhere here, correct? If it was 2, then anywhere here. Now x is 0. So you don't have to move that way or this way. So you are on y axis now, correct? So you are on y axis. Your complex number could be anywhere here, positive y, correct? So anywhere. If y is negative, it could be on the negative side as well. We don't know the value of y here, right? So now, so is it on the real axis? Real axis is x axis. No, it is not on the real axis. Therefore, it is on the imaginary axis. Is it on the origin? If the complex number is on the origin, then even y should be 0, right? Because this point is 0, 0. X is 0 and y is also 0. But it is not. You have got somewhere here. Okay, anywhere. So it is 0, y. Okay, so it is 0, y. So it could be anywhere. The value of y is not known, therefore it can be anywhere on the imaginary axis, and that's the answer for your question number 3. So option A is the right choice. Well, let's move to the fourth question. The fourth question, you have got the modulus sign here, correct? So this is 1 plus I and then 2 plus I divided by 3 plus I is equal to. Understand one thing, if you have Z1 by Z2 and modulus, you can take the modulus separately, right? And if you have multiplication of two complex numbers and then you have to find the modulus, you can find the modulus separately and then multiply them. Alright, so these two formulas can be used here. First you have got multiplication, therefore I can write this is equal to modulus of 1 plus I, yes, into, so now I can separate it. This is like this is Z1 and this is Z2. Okay, so I can write modulus of Z1 into modulus of Z2. So into modulus of 2 plus I divided by 3 plus I. Now this, let me keep it as it is, and here what do? Use this formula. So you have got Z1 by Z2. So how do you write it? Mod 2 plus I divided by mod 3 plus I. Now it's only the modulus formula that you have to employ here. So let's use that formula. What is the modulus? Square root of x square plus y square. Well, you have got x1 and y is also 1, I into 1, correct? Okay, so this is like square root of 1 square plus 1 square. Well, and into, so you have got root 2 square and then 1 square, because b is y is 1 here, right? Divided by here you have got 3 square and then 1 square again and 1 square again. Let's continue. So next, see, this is 1 square is 1 square is 1 plus 1 which is 2 into, this is 4 plus 1 divided by 9 plus 1. So that's like root 2 and then root 5 divided by root 10. So this is like root 2 into 5. We can use this formula because both are positive. 2 is positive, 5 is positive. We can use it. So that is root 10 divided by root 10, which is equal to 1. Hence, the answer is option B. Well, so that completes question number 4. Let's move to the next question. Hello dear students, let's look at question number 5. If z is equal to 7 minus I divided by 3 minus 4I, then find modulus of z raised to 14. There you go with the options. Now let's write this in the form of a plus ib. Okay, then let us find its modulus, because what is the modulus of z? Square root of a square plus b square. If z is a plus ib, so we have to write z in the form of a plus ib first. So what do? Rationalize. So multiply and divide by the conjugate of the denominator. So this is what you got to multiply and divide. Well, so let's go with the multiplication. 21 and then 28i and then minus 3i, so minus 4i square. Divided by, this is a plus b into a minus b into a plus b, the same. So 3 square minus 4i the whole square. So that's like 21 and then minus 4 and into minus 1, value of I square, and 28 minus 3 is 25 I divided by 9 and minus 16 4 square and I square. Okay, 16 I square. So let's continue. Well, that's equal to 21 plus 4 and plus 25i divided by 9 minus 16 minus 1, which is like 21 plus 5, 25, and then 25i, 9 plus 16. So what is it? So that is 9 plus 16 is 25. Cancel out 25. If you take common, 1 plus I is what remains here. So this is z and that is 1 plus I. Now what is modulus of z? Square root of a square plus b square. A is 1 and b is also 1. So that is square root of 1 plus 1, which is root 2. Now what you got to find? Raised to 14, right? So that's like root 2 to the power 14. Now you can write root 2. This 14 you can split. You can write 2 into 7. Correct? So now what is it? You can cancel square root and square. So which leaves 2 raised to 7. So option A is the right choice for 5th question. So let's move to the 6th question. This is just finding the modulus. So how are you going to find its modulus? You can find the modulus separately and then multiply the values. So that's the easiest way we can find the modulus of a complex number. Well, so question number 6, you just have to find the modulus of 1 plus I into root 3 into modulus of 2 plus 2i divided by modulus of root 3 minus I. So what is the modulus of this? Square root of 1 square and plus root 3 square into root 4, 2 square, let me write it. So this is also 2 square divided by see what is here, square root of root 3 square plus minus 1 square, because this is like root 3 plus minus 1, right? So that is like root 3 plus I into minus 1. So a and b, a is root 3, so a square, plus b is minus 1, so b square is minus 1 square. I hope you understood that. Yes. So let's continue. So here you will get 1, and what about this? Yeah, square and root cancel, so 3. And then here 4 plus 4, that's easy to understand. And here again root 3 square is 3, right? And then you have got minus 1 the whole square, which is plus 1. Always remember the formula is a square plus b square, so don't write minus here. Okay, so this is 1. Let's just simplify that, and that's your final answer. So I'll continue here. Look at this, you have root 4 and then root 8, 4 plus 4, and this is root 4. So root 4 is 2, this is also 2, that will cancel, so you can cancel out straight away instead of writing one more step, right? So you are left with only root 8. So root 8 can be written as root 4 into 2, that is like root 4 into root 2. So now what is square root of 4? That is 2, and then root 2. Well, so that's it. Option D is your answer, and that's the end of this modulus and conjugate. So thank you for watching. In the next class we'll solve the questions on the next topic of complex numbers. Once again, thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.